Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-6 lesson on writing polynomial functions. In this one, we will be writing functions based on their graphs. We're just going to dive right into this one. On this example, they want us to give a possible equation for this polynomial graph shown. Now, the reason they're saying possible equation is because there's actually an infinite number of functions that will give you the behavior of this graph, that will cause you to flatten through the origin, bounce off of 3, and overall go infinitely up as you go to the left and go down forever as you move to the right. But we're going to give one of those possible equations. And I'm going to show you this kind of in slow motion. You don't need to do nearly as much work as I'm showing here on future problems like this, but I just want to spell out every little step so that we get it right. So first thing we're going to do is we're going to talk about the different factors that are going to be in our function. So we're going to write our factors based off of the roots that we see on the graph. For example, we're going through the origin, so we have a root of 0. That means we have a factor of x minus 0. It's always going to be x minus whatever the root is. So we've got x minus 0, which we could also write as x. And for this other root here, 3, that gives us the factor x minus 3. Now that we've got those, we actually have to put some exponents on them, maybe. So we're going to use the root behavior, flattening, bouncing, or crossing, in order to write the exponent on each of these factors. For example, we know that we're flattening through 0. That means that the factor that comes from 0, this x here, needs to be cubed. So we're going to have an x cubed in our equation. Now, since we're bouncing at 3, that means that we're going to have x minus 3 squared. It's got to be a double root. So we're almost ready to put it all together. There is one more thing that we need to take into account, though, and that is that the whole thing, based on n behavior, might be negative or positive. So specifically, we're going to look at the right end behavior for the overall sign of the function. Because if you remember, basically if you have a positive overall function, then no matter what it's doing to the left or to the right, eventually its positivity is going to drag it up. If you have a function that's going down, it can only be because you had a negative overall sign that dragged it down in the long run. So in this case, since we're going down as we move to the right, that means that we end up with a negative sign in front of the function. So putting it all together, we have a y equals a negative, and then we're going to write our factors. Now, I always put x before any of the other factors. So we're going to have an x cubed because it was a triple root, and then we're going to have this x minus 3 quantity squared. And this is a possible function for what you see in the picture there. Here's another example for you to try, giving a possible equation for this graph. So pause the video and show as much or as little work as you like. I'm not going to show any work, but I will talk you through it after you've given it a shot on your own. All right, let's see how that went. So first thing I'm going to look at is the overall sign, because I'm just going to do, left to right kind of thing here. So I noticed that this graph is moving down as I move to the right. So automatically I know I have a negative out in front of everything. Next, let's talk about our factors. And I always look at the origin first when I'm looking at factors, because if I have an x, I'm going to put that in front of any of the parentheses with x minus numbers. So we are going through the origin, so that means we have x to some power. Now, since we're bouncing at the origin at x equals 0, that means we have x to the second power, so we'll have an x squared there. I also noticed that we're bouncing off of 3, so that means that we have a factor of x minus 3, and that factor is being squared because, again, we're bouncing. So x minus 3 squared. And that's it. For this next example, they want us to find the specific equation for this graph below. Now, there's an infinite number of equations that will give you a polynomial that bounces off -2, crosses through the origin, and goes from up to down as you move to the right. But there is only one polynomial equation that will do all of this and also go through the specific point 1, -3. And that's the polynomial they now want to see. Now, in order to make your possible equation actually go through a specific point, you have to stick a coefficient out in front of the entire equation. So what we're going to do is we're going to write the general or possible equation just like we did on those last examples, but we're going to have a mystery a constant out in front. So pause the video and see if you can write a possible equation for this first, and then just stick an a out in front of it. All right, now hopefully in the course of writing this, you recognized that since we're going down as you move to the right, we again have a negative out in front. So I'm going to now write negative a, y equals negative a. And we don't know what a is yet. We'll find it later. Now let's take a look at our factors. Since we're crossing through the origin, we have a factor of x, and it's going to be the first power because we're crossing through. So this is just x to the first power. And we're bouncing off negative 2, so we have a factor of x plus 2 that is being squared. So x plus 2 quantity squared. So there's a possible equation, but now it doesn't become specific until we solve for a. How can we solve for a? Well, in order to solve for a variable, you have to make sure there's no other variables. So we need to plug something in for x and y. What could we plug in? Well, we know that the graph goes to the point 1, negative 3. So at this point, no pun intended, we are going to plug in the point they gave us, the given point, and solve for the a value that's remaining. So for y, we have this negative 3, the y value of the point they gave you. So I've got negative 3 there. And for x, I'm going to plug in the 1 that was part of that given point. So I'm going to rewrite the right side of this equation as negative a times 1 times 1 plus 2 squared. And now I just solve for a because it's the only unknown left. So this is going to be negative a times 3 squared. So that's negative 9a. And then if I divide both sides by negative 9, negative 3 over negative 9 can be reduced to 1/3. So that's my a value. Now you got to be careful because you probably feel a sense of accomplishment at this point, but you're not done. We actually need to rewrite the general equation with a plugged into it before the problem is finished. So just going back, we write y equals negative 1/3 x times x plus 2 squared. And now this is the specific polynomial equation that matches this graph, including that point. We'll do one more example where you have to write a specific equation. Pause the video and try this one out. All right, let's see how that went. So writing our general equation with an a first, we notice first off that we're going up as we move to the right. So the whole thing is going to be positive. So I'm going to write y equals positive a. And then let me write my factors. Now the origin is one of my roots here. 0 is one of my roots. So I have an x for a factor, or an x minus 0. And I am flattening as I go through there. So that's actually going to be an x to the 3rd power, triple root. Looking at my other factors, and it doesn't really matter what order I write these in, I'm just going to go left to right at this point. The only time I care about the order is putting that x first for the origin. But for the rest of them, we've got minus 3 is one of our zeros. So that means we have a factor of x plus 3. And since we're crossing through there, we just have first power. So this is just x plus 3 with an invisible 1 for the exponent. And we're also crossing through negative 1, so we have a factor then of x plus 1, or x minus negative 1. So there's our general equation. We still need to find the a value, though. So let's plug in the point that they gave us. Now, in this case, that was the point right here, negative 2, 10. So if we plug that in, we've got 10 for y, and we have negative 2 for x. So that's a times negative 2 cubed times negative 2 plus 3 times negative 2 plus 1. And let me deal with these other parentheses first. Negative 2 plus 3 is just 1. Multiplying by 1 doesn't do anything, so we can ignore that. Negative 2 plus 1 is negative 1, so we have a negative 1 hanging around out here. Negative 2 cubed is negative 8, so negative 1 times negative 8 gives us positive 8. So when the dust settles, we can write 10 equals 8a. Dividing by 8 to get a by itself, that ends up giving us 10 over 8, which we can reduce by 2's to get 5 over 4. So there's our a value. And as always, don't forget to plug it back into the original. So we have y equals 5/4 x cubed times x plus 3 times x plus 1. So that'll do it for writing polynomials from graphs. Till next time, Mr. Sutton signing off.